welcome. Welcome to this SCI webinar on the art of the possible, data, digitalization, and AI in practice. Um, uh, this is a webinar that is both for information now and an advert for, as you'll see, a conference that we'll be running next year. The program today is, after a welcome from me and a brief reminder about what the SCI does and is doing, having a talk by Mike Houghton from Siemens on digitalization supported by AI, unlocking the next level of productivity and innovation. Try and give you an idea what all this AI is about. What's it going to do for you? What is it actually going to make difference for your companies? And then, as you'll see, that data is very important in this. So Samantha Pearman-Kanza is going to, from a somewhat academic perspective, talking about how we can get the data to be fairer, make it available, what is needed in the chain of for digitalization and to be able to use AI. What do we actually need to do to make sure that data is available and useful and collected appropriately? So give you two sides, if you like, of what's going on. And then we'll have a short period of time for some Q&A. Okay. So my name is Jeremy Frey. I'm at the University of Southampton. I'm a professor of physical chemistry in the School of Chemistry and Chemical Engineering. We're now a joint department. And my interests are in the digitalization of the whole of the chemistry research and development chain. I've been involved in a number of initiatives in the UK, starting from the mid-2000s, the e-science program, the digital economy program, ran with, in fact, Samantha, the AI for Scientific Discovery Network, and I'm now involved in one of the UK AI hubs and a project around the physical sciences data infrastructure to try and provide this underpinning data structure, data and data availability for one major area, which would be AI. So I've been seeing this slow and increasing pace of digitalization of the chemistry supply chain, let's call it that way. Okay, so I think move on to the, and then here you'll be able to recognize them when they're speaking. Mike Houghton from Siemens, who is on the SCI committee around data and digitalization, and Samantha Pearman-Kanza, who is a senior enterprise researcher at the University of Southampton. So as I mentioned, this webinar is also as part of a sequence of things we will be running to highlight a conference around data and digitalization and AI in 2026, towards the beginning of September, running at the SCI's headquarters in London. And we'll build upon this today's webinar and some other events that we'll be planning through the year for a two-day conference to bring together industry experts, innovators, technology leaders, and explore the practical aspects of digitalization, digital transformation in chemicals and manufacturing. So at this, we will expose you to cutting-edge industry cases. You'll get a few ideas of that from Mike today. There'll be hands-on demos from vendors and technology showcases, some panels so that you can hear actually from people who are already in this process of digitalization, automation, and leaders in AI. And the whole idea is to actually show real-world problem solving. What is this AI and machine learning stuff really going to do for you, and what do you need to do to be ready for it? So we don't yet have the webpage up, but it'll go up soon, and we've got all your contact details. So Callum and Nathan will be sending out details to you as soon as we have more about the conference. Okay, so we can move into the meat of the webinar and start with Mike. So Mike has been a member of this committee on data digitalization, AI, from the beginning. And whilst we saw that quite a number of areas of the SCI, the specialist interest groups, were looking at AI, whereas there wasn't really anywhere where the breadth of AI and impact of digitalization was really being considered. And this is what this group is about, is trying to bring that understanding across the board to the whole of areas of chemistry, industry, and production. So Mike's been working at Siemens for quite some time and has a whole series of interesting applications of AI to tell us all about.
Okay, so thanks for the introduction and the kind words. So I'm Mike Houghton. I'm the Chief Commercial Officer for Siemens Software in the Process Sector. Been at Siemens for quite some time now. I'm an engineer, a fellow with the Institute, so you can ask me questions later if you want to know any more. And today I'm going to present just some key insights of how we use AI. I'm going to give you some examples from adjacent industries as well, to move at a different pace than the process sector to give you some insight for what the future might look like. There's a lot of concepts to get across here today. It's been recorded, so you might have to look back at it, but feel free to ask me questions at the end. And it's by no means meant to be comprehensive on any one topic. I'm just giving you the splash and dash, as it were, for what we're doing elsewhere as a leader in this technology in the marketplace. So, first off, I wanted to talk about when we talk about AI. When we talk about AI, we talk about industrial grade AI. So you're all familiar with large language models and what they give you. But when we talk about AI, we talk about industrial grade, and we've got foundation modeled information that we feed our industrial foundation model. So we've got the vocabulary that's important. We've got mechanistic models, and we combine those with deep process know-how. We've got time series data, 1D, 2D, 3D data sets, diagrams, a whole host of stuff that forms our, I'm going to say, our industrial foundation model. And with that, we get reliable outputs. We get a higher degree of fidelity and accuracy. It's trustworthy and it's explainable. You know, most often when you've got a large language model, just to say with, let's say, OpenAI, finding the origins of the data can be challenging. And in terms of use cases, we've got generative designs, we've got surrogate models, test and simulation, production data, optimization, change management, a whole host of things. So we try to differentiate ourselves from just pure AI. We call that industrial grade AI. And you'll see some examples of where that is in the next couple of slides. So what do we use it for? Fundamentally, we create comprehensive digital twins. Now, those digital twins are based on, I'm going to say, that AI, and we, in this case, I'm calling it a hybrid model, and we use that data right across from the design to build to operate, and it allows us to simulate and assess performance at any part of that life cycle process. Right, and at the end, we even move into what we call our closed loop or executable digital twins, where we're taking that twin data and having it run in parallel to the real process to inform the best avenues for change to move into a corridor of operation. Right, and that could be CO2, it could be yield, it could be quality, it could be energy consumption. Wherever you want that corridor of operation to look like, you can do that with that technology. We also talk about the industrial metaverse, and I'll come into some examples about bringing this to life in the subsequent slides. This is how we bring it to life in a way that was unthinkable a few years ago, almost making it real, a digital twin that runs next to the real process. And again, I bring that to life in a few slides, but it allows people to make informed decisions and be able to see what that design and what that twin looks like before actually moving into the real world, as it were. Okay, now this is an example of a metaverse industrial twin. You can see it's an FPSO, a vessel oil production. It's essentially a production platform that sits on the sea, and you can see here the digital twin is looking at, or the metaverse is looking at the digital twin and almost at a photographic value. You can see how it looks, but I can now slice and dice that to any which way I want. There's 9 million components on this vessel, and then I can begin to not only look at it, I can simulate. And in this instance, I'm doing some computational fluid dynamics for vessel stability and how that vessel is going to move through the ocean, but I could be looking at any part of the process there. So the twin, that's just an example of bringing it to life in such a way I could be actually looking at a component, maybe a separator vessel or whatever else it might be on that vessel itself. I can look at any component in that industrial metaverse, right? And that's just a real simple example of what we do. I also want to talk about using these AI models to create a digital thread across the entire life cycle. So there's lots of really good technology out there that are good point solutions, but unless you can thread that data from right across the entire life cycle, that information becomes almost like a data silo or data jail, as we very often call it. So the real value moving forward with these digital twins and these AI models is how you liberate that data and make it available across the entire life cycle. And that allows you to move with speed and agility and drive competitive advantage as production facilities need in this common marketplace to unlock. Now, I'm going to give you some examples. Siemens has been at this for a long time. So I'm going to start with this. So you all might remember this. This is the Mars space rover, the Curiosity project. You might not know, but this was built and designed on our technology. There's a nice little video here. If you go to this video, you'll see it online. I think it's called 7 Minutes of Terror, where the actual Curiosity rover descends onto the surface of Mars. And there's one particular one where they talk about the simulating how they slow down this satellite object to land on Mars. It's moving at supersonic speed. How do they slow it down? And there's in one instance on the parachute, there's I think 60,000 simulations they go through to get it right. It's a fascinating video. Watch it if you will, but it gives you an idea of what we've been doing in adjacent industries. If I now move that forward, SpaceX, you see that that rocket go up and come down. And what you might not know, again, is that's all built and designed on our technology, right? And he's moving at pace that only NASA can dream of at the moment. I've got to say NASA uses technology, but this guy is pushing the envelope to what you can actually do with those digital twins and bring them to life in terms of a real production vehicle that's able to move satellites into space like no other and reusable as well. So again, fantastic. And he's got some interesting statistics there in terms of productivity and reduced composite times. But moving on to another adjacent industry, and I just like this one. And I wish I was sitting here saying to you, you know what? I know a Brit won the world championship, but that's our car. And this is a car that's built and designed on our technology, right? And again, why is that important? So this car, you might know, only about 10% of the car survives the season in terms of what it started the season as. That's except the engine and the wheels, they survive the season, but they're constantly innovating this car to just drive competitive edge and make sure the world champions or the runners-up in this instance, right? They push it all the time. So they can go from an idea, right, to in silica design, to simulate offline, to building a prototype, maybe with 3D printing and the likes, to put onto the race car in a matter of weeks. Within a month, they can get from an idea to on a car. And that's the speed of pace these digital twins allow you to operate. But also, I want to come back to that digital threading becomes really important, right? And if you then move into the automotive sector, automotive, they run on a productivity of around 8% to 13% year on year. And those figures come from JLR. I used to chair a group on advanced manufacturing up in the Northwest, and remember them telling me this. And they can only do that by having this digital backbone driving that level of innovation. Now, again, I was on a symposium earlier this year with BASF CEO. And when I said this, I said, what's your productivity you drive in your process sector in terms of operations? And he said, I'll be lucky if I get 1%, Mike. So there's a lot to unlock there. That's the key message. So now I'm going to just do a bit of a deeper dive on pharmaceutical. I'll talk about tech transfer because that's a subject that everyone knows. So we all know about drug discovery. It takes a long time. You get lots of candidates in the funnel. It takes 8 to 10 years through I'm going to say the various stages of trials and clinical trials, etc., before you get a compound that you can release and that's approved. And then you've got to get that to market really quick. And this becomes about capital employed, and that tech transfer becomes a real challenge. How do I make sure that I'm not investing? I'm investing as late as possible, because your candidate could still fail last minute, right? It's approval process. You want to make sure that if you're spending 100, 300, 500 million dollars, whatever it is, on that production facility, you want to do it as late as possible, but you want to be assured that it runs and operates the quality criteria that you need to get out to the market, because you're burning, if you like, that wick of time in terms of your patent rights to that product. And combined with that, you've got lots of challenges. This is only 1 in 5,000 drugs makes it to approval. the ROI, it used to be 6.5%, it's now 1.2. The cost of bringing a mega drug to a mega brand to market has gone from 2.6 billion to 6.7. Tech transfer, average 30 months, 20 months. And then once you get into operations, you've got lots of challenges. About 60% of the drug shortages once you're in production due to poor quality production. You've got OEE statistics of around 35%. We know whether in markets that we operate in are up to plus 95. And, fewer than 20% of AI adoption in the pharma manufacturing process. So there's a lot of opportunity for scope there in terms of improvement. So what we want to do is we want to be able to rapidly design robust processes for that tech transfer and scale up from lab to production. I can remember in my early career, I did a lot of work at Pfizer. I built their facility in Sandwich, where they went from desktop to kilo lab reactor to pilot production facility to then full scale. You'd never build that today. You do most of that in silica with then some sort of, I'm going to say, calibration techniques on this. So this is typically what you go through. You've got the tech transfer, you've got speed, compliance, costs, sustainability you're looking at. You've got design, your digital design of your products and processes. You've got knowledge-driven recipe transformation, manufacturing verification, optimization. And this is just some feedback. This is no comprehensive, but I'll just share. These are pharma companies that are using our tech. And again, I'm saying this as Siemens, but there are other suppliers out there that do similar sorts of stuff. So Takeda saying that they got $1 million worth of saving on process development. The GSK here, 25% reduction in their experiments, 80% reduction in material usage here, and then Novo Nordisk, 50% reduction in time to market. Johnson & Johnson, minus 25. So these are real numbers using that digital technology and that backbone, using those AI generative informative models, as I mentioned earlier. That's what we're delivering. That's real practice. So again, I'm just going to give you an example of other metaverse examples. This is you can see there's a manifold for these reactors and blenders. And what we're doing here, we're not just simulating what's happening in the vessel. We can simulate how operators work and how we move material, flow around facilities. I'm going to show you another one that will give you a lead in. This is, you might remember CPI. This is one we did for them. And again, bringing it to life in a way that, hopefully doesn't make you too dizzy when you look at this. It's a few minutes, this video, but it gives you some quite interesting insights to the sorts of thing you can do. So here, it's just looking at oral dosage, filling line. What could that, in this instance, what will this look like? What are all the processes need? In this instance, it just looks like material flow, but you could also be using labels, verification, pharma code information, right labels, right packaging, all those things. You can fly through any part of the facility here. This is some sort of reactor hall here. So now you're doing computational fluid dynamics of what's happening in the vessel. And maybe you're looking at the synthesis of what's happening in the reaction as well, using our technology. There's a whole host of things you can do here. I'm going to cut this video short because time's going to run out otherwise. But you get the idea. This is how we see the industrial metaverse and bringing the real worlds and the digital worlds together, and being able to make those more informed decisions and get better outcomes in terms of accelerated product to market and the likes. So, two other topics. This is just another example. There's a company in Austria, and they do turnkey solutions for biopharmaceutical facilities. Don't worry about the technology here. I guess I just want to bring you to what's in yellow on the bottom here. So, they're getting their projects to market. So this is once we've identified what we need to do with tech transfer, and now we want to minimize the time their net capital is employed before they get the product to market. And normally a project of this nature would take about 48 months, and they're seeing cycle times reduced to 24 months using that digital backbone using a holistic view as, say, AI-informed models. You've got those digital threads supporting this. They're bringing it down to 24 months. That's a fact. That's not just, you could do this. These are facts that we're actually delivering into the marketplace right now. And finally, I just wanted to give you a bit of an insight, and hopefully you can hear this video. So this is what the tool set that we use internally to support not just our technical people and our salespeople, but also to open discussions with our customers. So I'll let this video run, and this is an avatar that allows us to explain the merits of using the technology for different stakeholders.
Hi, I'm your Siemens digital assistant here to guide you through our accelerated product development digital thread. Ready to begin with engineering planning?
Good morning, Katya. My name is Stephen, and I have got some questions for you.
Good morning, Stephen. I'm here to help. Please feel free to ask your questions.
Can you give me the advanced technical explanation of Siemens APD and assume I have a master's or PhD in engineering?
Certainly. Siemens Accelerated Product Development, APD, leverages the digital thread to integrate requirements management, design, simulation, and manufacturing in a seamless, traceable workflow. It connects multidisciplinary domains, such as mechanical, electrical, software, and systems engineering, using integrated tools like Teamcenter, NX, SimCenter, and Polarion ALM. This ensures early validation, risk prediction, compliance with standards like REACH and ROHS, and accelerates iterative cycles through automation, real-time data synchronization, and multi-physics co-simulation, enabling faster, more reliable product delivery.
Can you now simplify that for me and explain it to me like I'm a junior engineer or an intern or just somebody new starting at the company?
Of course, Siemens APD is a digital platform that connects all parts of product development, requirements, design, simulation, and manufacturing into one smooth workflow. It helps teams validate ideas early, predict risks, and make faster, better decisions by automatically sharing data and using advanced simulation tools. This way, you can develop new products quicker and with higher confidence.
So finally, I have one final question. Can you explain it to an executive who's considering a reorganization and wants to understand how APD supports better collaboration and reuse?
Absolutely. Siemens APD streamlines collaboration across all teams by providing a unified digital environment where data and decisions are shared in real time, reducing silos and miscommunication. It promotes reusability by managing digital assets like requirements, designs, and simulation models centrally, enabling rapid reuse of components and knowledge across projects, which accelerates development and lowers costs. This integrated approach enhances teamwork, improves consistency, and drives faster time to market.
This has been a great help, and your answers were fantastic.
Well, you get a bit of an insight there. So we don't just use the AI on our models, we actually use it on how we take our portfolio to market as well. So I hope that was interesting. Some nice insights there. I know it was a whistle-stop tour, bit of a fly-through, but I'm happy to field questions at the end. So thank you for the time and listening, and talk later. Thank you.
Thank you, Mike. That's just amazing, just how much, if you can get into this digital arena, just how much you can get done, and just huge swathes of what companies do that you can come and influence. But so passing on to Sammy now, you mentioned at the beginning, Mike, that you need to put the data in, you need to put the models in, you need to put, so really just shows you, especially for companies starting out on this, that you've got to assemble that data, and I'm sure Siemens has ways of helping you do that. But fundamentally, there are lots of issues where I really think that many of us in the academic arena and in some companies don't understand the value of what we do sometimes for other people, and actually making sure that you can share this data to yourself later is what we tell our students, who they won't remember what they were doing 2 years before when they come to write up their PhD. But this is for companies, this is money. This is real costs. Academia is just lost opportunity and money. So Sam, if I pass over to you to talk about data stewardship.
Fantastic. Well, hi everyone, and thanks for inviting me to speak. So yeah, this obviously Mike's talk very much focused on the AI and the kind of fancy futuristic things we can do. I'm very much going to talk about the data. I'm always talking about the pre-AI and the considerations for AI. So I'm going to give you a really brief intro to me, given that we don't have much time. And oh gosh, I normally have at least an hour to talk about these things. So this is very much a whistle-stop tour of a few different things. But the kind of key areas I want to focus on, I want to talk about the importance of fair data and data stewardship. I'm going to talk about a really successful case study we've been working on of using fair digital tools in the lab. And then I did really just want to make a note about ethical AI, because that's also really, really important. And then talk a bit about how we can kind of blend these things together for sort of better data for our AI. So I'm coming to you from, I have quite a few different hats, but you might sort of see where I'm coming from for these projects with the first three, is I'm the principal investigator for CASDAR, which is the Careers and Skills for Data-Driven Research Network. I'm also the co-investigator and Pathfinder lead on process recording for the Physical Sciences Data Infrastructure. So this is kind of where the data stewardship and the fair tools in the lab comes in. But I'm also deputy chair of the Faculty Ethics Committee, and I've been working a lot on the ethical considerations of data. So these are all going to kind of feed in to the different bits I'm talking about. So we have so much data. We have so much data that it's crazy. And so Jeremy mentioned the AI for Scientific Discovery Network that we both worked on. So that was a few years ago now. But every single meeting we had, people always said, we don't have enough good quality data. And even though our data is growing constantly, unfortunately, that is still true a lot of the time. So we might have more data, but it's still stored in random places. People can't find it. If you can find it, the chance of you actually being able to understand what it is and use it, even that if that's your own stuff, let alone other people's, is actually still quite low. We have a real problem with researchers reporting things that aren't reproducible, that aren't reusable. How many of you look at a research paper and you can't find the data associated with it, or the data is just, a bunch of graphs in a PDF. You don't actually have any idea what the raw data is. There's actually been a lot of scientific papers published about how unreproducible a lot of scientific research is. And ultimately, so much of this research, whether it's being funded by public money like we are, and we're meant to be putting that back into the community, or whether industry's funding it, a lot of that, unfortunately, is being wasted because people are doing a lot of work, they're generating a lot of data, and they're not taking the care to actually produce it with the necessary quality and information that other people can make use of it. And everyone kind of says, well, but fair data is fixing that, right? That's the thing we have to adhere to. And if we just adhere to fair data, everything will be fine. And fair data is a really good start. So I'm sure most of you do know about it, but just in case, it's a set of principles actually derived in 2016 now to make data findable, accessible, interoperable, and reusable. But FAIR was actually defined a lot around sharing the data. And they are fantastic principles for sharing data. But if you actually, I could go into this for hours, so I don't have time to kind of fully go through it. But if you actually go and look up the reusability principles, yes, it has the word reuse in the name, but actually they mostly talk about how you can enable people to reuse your data. So it's about sort of adding metadata to understand what's in it and adding metadata to understand how you're allowed to use it. But none of that actually tells you how to make data that is worth sharing, that is actually usable in the first place. It doesn't talk about data creation. And unfortunately, so from a lot of the projects I've worked on, Jeremy and myself have worked on a number of different data projects, including a notable agricultural one I remember, where we had to integrate a load of different data sets, and they were of, let's just say, very questionable quality. And we were trying to transform this data, we were trying to aggregate it, we were trying to mark it up using consistent terminology, but so much of it was very poor quality. Things were missing, things were inconsistent, and there's only so much you can actually retrospectively fix those things. So yes, of course we should be adhering to FAIR, but FAIR is something you think about all the way through, but you sort of enact closer to the end in terms of actually marking up and labeling your data. But we need to think about how can we create data better in the first place. And to do that, data needs proper stewardship across the entire research data lifecycle. It's not enough just to say, oh, we're going to create some data and then think about how to share it nicely at the end. And it's not enough just to think about these things at the end. We need this stewardship across the whole life cycle. So we need to think about the planning stage. So the planning stage is really, really important. what data are you creating? What are you collecting? How are you doing it? How are you, and again, I imagine these are a lot more prevalent in academia than industry, but we have these things called data management plans, where you are actually meant to kind of go through and document all the different data you're going to be using, creating, collecting, and what you're actually going to do with it. You know, tailoring this to the research. So are you actually collecting and creating relevant data? You know, does your data collection need ethics? I'll obviously talk about that a bit more at the end, but that's really, really important. How are you actually going to store this data? How are you going to then think about sharing it with other people? Where are you actually going to put it so that other people know how to find it? How are you going to document it? How are you going to license it? What are you going to do if you have multiple data sets or you're using code that have different licenses? There's a lot of different things that actually need to be taken into account when you think about creating properly usable data. And unfortunately, it is so much more than just FAIR. And I think the problem is people kind of stick to FAIR, that there's FAIR assessment tools, there's checklists, and people kind of think if they've gone through those, they've checked the boxes. But actually, you don't just need that. You need all of these different skills, all the way from planning and what you're doing at the beginning. And also something I always think is really, really important here is planning for how you're going to explain missing data. You know, if you do a survey and certain questions aren't required, but you don't provide that information to other people, then you just have missing data. Does that mean it's negative, or does that mean it's missing? You have no idea why it's still there. If you're doing a daily set of experiments and you're missing one, why is that? Did you lose it? Were you ill? Did the lab blow up that day? You know, there's also a lot of kind of additional contextual information that doesn't come in, that again makes it really hard for people to use your data. And again, if you're trying to train an AI with data, you actually do want better structured, richer data. You don't want random stuff that the AI then potentially has to make up and fill in the gaps for. So what I've kind of been trying to get at here is implementing FAIR requires a hell of a lot of these diverse skills. If we're going to assume that actually we need to go through all of those phases to make our data reusable in the first place, and then enact FAIR, this is a lot of skills. This is a lot of skills to get in one person. Should we actually expect all of our researchers to have those skills? I mean, to me, absolutely not. You know, that's crazy. We don't expect every researcher to be a software engineer. We don't expect every researcher to be a legal expert if they have to work with non-disclosure agreements and handle sensitive data. We don't expect every researcher to be an ethical expert. That's why we have ethics committees. So I also don't think we should be expecting our researchers to have all of these data skills. And the amount of times people say to me, the FAIR doesn't work, it's too difficult, we just can't make good quality data, we should just give up. And I'm like, okay, but how much money and resource and time and people are you actually putting into making your data better quality? Because everybody's kind of obsessed with getting to the AI point over here, but they're not investing in creating the better data for it in the first place. And to me, if we're going to make this work better, we actually need to have the researchers with the domain skills, people with the relevant technical skills to make these tools, and the people who understand how to make this data better. So what I'm ultimately saying is we need data stewards. We need the people that can do all of those things I just showed in that previous diagram, so that we can create data that is actually worth sharing, that you can understand when you go back to it, and that other people can understand it, and that we can actually start making use of our data, whether that's other people building on it or AI systems building on it. This is where one of my projects comes in. So CASDAR, the Careers and Skills for Data-Driven Research Network, we are building a network of data stewards, because data stewards, unfortunately, aren't particularly well established, certainly not in the UK. They are better established in some of the European countries. And they fall under the digital research technical professional pathways, so alongside things like software engineers, research software engineers that are actually much better recognised, but also along kind of data scientists, infrastructure engineers, all of those kind of positions that really actually support producing excellent research outputs, but that aren't necessarily formally recognised and don't necessarily have some of those formal career paths or obvious trajectories to get into this work. And at CASDAR, we think this is so important. So we're creating this community, we're establishing data stewardship. So we're actually funding a lot of different people to do data stewardship projects. I will again sort of briefly mention that at the end, because we've currently got an open funding call, but we want to learn all about the different people doing different types of data stewardship work. And ultimately, you know, I mean, don't have so much time to go on this, but you can find out all about kind of our deliverables and our plans on the website. But I guess what we're really trying to do is promote that people need this human effort and all these human expertise if we're going to create better data. If you're interested in CASDARs, you can join our mailing list. So I promise we don't spam, we federate the mailing list, but you will get kind of updates. We run quite a lot of events. So we're going to be running a big data stewardship conference in November. So if you're interested in data stewardship, please do come along. We also have quite a lot of webinars of different people telling their data stewardship stories. So that you can see how other people have done this work and the sort of difference is made to their projects. We've recently launched Discord as well, of kind of informal chats. And again, for people to knowledge share about data. You can apply to our funding call. We are actually running a support webinar on Friday about that if you want to come along and learn more about that. And we will also be putting out kind of an open fund for people to run events with this. Again, whether that's kind of knowledge exchange around data stewardship or training events or relevant workshops. We ultimately want to support the data stewardship community. So that's a bit of a whistle-stop tour to kind of why I'm involved in CASDAR and why I think data stewardship is so important. Another thing I really wanted to talk about was the need for sort of fair digital tools in the lab. Now, obviously, we need fair digital tools everywhere. I'm focusing on the lab because this is the other area that I work in. And electronic lab notebooks is one of my absolute favourite research topics. I've been researching it for the last decade. It was an area I worked on for my PhD. But ultimately, if we think about science and scientific research and the fact that actually still quite a lot of people use paper lab notebooks, and again, scientific research itself isn't particularly reproducible at the moment. There's a lot of problems with, again, people publishing papers and people not necessarily being able to reproduce or build upon people's existing experiments. So one of the solutions we've been looking at for this is electronic lab notebooks. So something to actually provide a kind of centralized, secure set of records for scientific research. So rather than having things scattered around in paper lab notebooks, not being able to find things, not being able to share things with other people, things maybe being scruffy, degrading over time, actually having everything in a nice electronic one place that you can search for and find things. But also, again, if we're going to actually use these digital tools, I think what's really, really important is that we add value. So I by no means think that science isn't reproducible just because people have it locked away on paper. I think a lot of people don't actually write down a lot of the relevant information at the time. They don't capture all the relevant information and data at the time. So, if we're going to implement these tools, we should actually really make sure that they're improving our data quality, that we're capturing more structured data, and that the research we're actually preserving is in a better quality than the research we would have started with if we just had, a stack of paper lab notebooks. But ultimately, if you implement these tools well, we do actually have a really good opportunity to produce, really robust, secure digital records that other people can build on, whether that's you sharing it as part of electronic supplementary information as a paper, sharing it with your peers in academia, but also, for you people in industry, surely having much better electronic records of all of your research can only be a good thing. So I just briefly wanted to also go through this essential case study of what we've done. We decided to trial electron lab notebook at the University of Southampton. We went across, so it's the School of Chemistry and Chemical Engineering. We were basically trying to understand, can we actually add value with this ELM? Will it enhance user needs and workflows? Will the school benefit from it? We've been trialing it for, I guess we had about a half a year set up. We had about a 9-month trial. Things have actually gone really well, and now we're rolling it out to the whole school slowly. Again, to actually make sure that we are capturing all of our research digitally. We've currently chosen to use Gravity Signals, mainly because it fitted a lot of our needs. It works for chemistry and it links in with ChemDraw, which is a tool that all of our chemists use. And we ran this across all of our different research groups to make sure we got kind of feedback from all the different types of chemistry that people do in our school. And then I just wanted to talk a bit about actually, again, making these tools add value. So, we did the traditional setup. We set up accounts and stuff so people can actually share information with each other, because there's no point putting digital tools in place if you can't share things. We have a data exit strategy that's really, really important. You should never be putting your data into a system you can't work out how to get it back out of, because otherwise you just get stuck in vendor lock-in, and then again, you potentially run the risk of losing data you might want to use later. But the bit I really want to home in on is this middle bit. We created structured templates, and we added a lot of metadata to the experiments. So now when people create experiments, they actually have a nice structured template to fill in. We're encouraging people to use better practices. We're encouraging people to capture more data and better data, and also, again, to capture it in a consistent way. And we're adding a lot of metadata automatically so that it's much easier for people to actually then find their own and other people's things. And we've also developed training around this. So we're not just saying, here's your tool, we're expecting miracles of you. We're actually trying to train people to produce better research in the first place. And this has been really successful. People want to keep going with it. They've actually logged, we're getting 120 experiments logged weekly. These would all have been scattered around in paper lab notebooks before. They're now all in a digital system. And really importantly, the group leaders have said, they've got a better oversight of their researchers' work. People think that it's actually improving the quality of their work. Again, I don't have a super amount of time here. Obviously, this was hard to set up. You have to think about your hardware and your setup of your labs. And if you are interested in hearing more about this, just ping me a message, because I have a whole much longer presentation about how we ran this trial. But also, interestingly, now that we've got all this in place and we've got people using this system, one of the things we are now looking to do is actually investigate how we can use AI tools to make things better. So now we've got everyone using the system, how can we use AI to kind of prompt people to say, oh, but what about this? And have you forgotten this? And you haven't written this in. Again, to try and kind of combine that human effort and that machine effort to actually enhance our research recording even more. And we're also looking at how we can then make ELNs interoperable so that people can actually share data in a consistent way across different systems. And I mean, really briefly, just to kind of go through this, like with all the things I tend to work with, these are human-driven efforts. We might be leveraging technology, we're using technologies, but actually implementing ELNs or implementing any technologies or tools around improving data management, improving the capturing of your research, there is no point just buying a license and blindly throwing it at somebody, however nice the piece of software is. You actually have to think about fostering that cultural change and that stakeholder engagement and user adoption, and actually getting people to understand how you're adding value and how you're going to help them and why they should be doing this, and train them and support them so that they don't just kind of completely disengage. I truly believe that if we are actually going to push towards having better research in all these different areas, that we really need to support our researchers to do it better. And actually the link I put at the bottom of this slide is for substantially more information about the trial, if that's interesting. So this work has come out of PSTI, the Physical Sciences Data Infrastructure. So essentially, we are trying to help promote research and data in the physical sciences by providing an infrastructure. And we provide lots of different services, but the ones that are probably most of interest to sort of this area is we provide access to trusted quality data sources, which again, there's never enough of those, and we actually provide access to those. So if you're looking for high quality trusted scientific data sets, you can come and look at our data. We also have tools to help you transform your data. So whether that's workflow tools, machine learning tools, we have interoperability tools to convert between different scientific file formats. Essentially, we're trying to make people's data lives better, and we also do a lot of community engagement. We run events for knowledge exchange and to sort of train people around these different areas. I recently delivered a whole set of training about electron lab notebooks. We collaborate with lots of different partners and different institutions, and we also provide quite a lot of guidance around different things. So in terms of specifically ELNs, we have a really cool service, the Data Revival company that Jeremy's linked in with. They provided a free version of their software where you can actually scan in your paper lab notebooks and convert it into machine readable data utilizing AI technology, which is very, very cool, especially as even if you were to implement digital tools now, you're going to have a lot of legacy data that needs to be turned into machine readable data if you want to do anything useful with it. We have a lot of case studies, guidance. We collaborate with it. We can contribute to a tool called ELN Finder, which is to sort of help you pick between different pieces of software. And we also run community activities. So we're re-establishing the research notebook community. So again, if people are interested in exploring kind of different success stories and how people are implementing these different digital tools for their institutions, do come along to those events. And then just, as I know I'm running over time, a sort of quick note about ethics, with my ethics hat on. Not all of you will use personal data, but, and this is coming from the academic side of things, but also, plenty of industry people collaborate with academics or are still kind of might face scrutiny from some ethics boards. Depends what you're doing. But what is really, really important is firstly think about what data are you collecting. Because if you're collecting any personal data, you will need to do it with informed consent. That's important. Even if you're not actually held to account by ethics boards, you should be held, you should hold yourself to account, and you should actually get people to consent to this data, particularly if you then want to put it into your training systems. If you're reusing data, again, it's really important to adhere to sort of reuse policies. And if you're analysing sort of secondary data, again, if that's got personal data in, you still need to be really careful and mindful about that. Bias and fairness. This is such a big thing, and it's always going to be a thing as good as the data you put into it. And if you don't diversify your data sets, and if you put data sets that only cover certain areas in, then your results will be supremely biased, and nobody wants that. We also need to think about transparency, both in terms of if you're using people's data in AI, what you're doing with people's data, but also if you're using AI tools as well. Use them, and using these tools mindfully and not just blindly believing what they say, because we're all aware that a lot of them can still hallucinate. I also think kind of a bit of a nod to sustainability. It's great we're using all these tools, but obviously it does take more power. It is more computationally expensive. So why are you using them, and what are the benefits? And also a really big thing I think about, that there's a lot of ethical decisions that humans still struggle over that we don't have the right answers to. Those should absolutely not be blindly embedded in AI systems. We shouldn't lose the human in the loop here. I think we can do really awesome stuff with AI now, and it's got a lot of potential, but I would still be really wary of writing out that human element. So I think it's also really important to think about how can we combine the best of human and machine, rather than how can we eradicate human with machine. So then, coming at this from this kind of very academic data-centered sphere, if you're going to use digital tools, you should use them. You should be actually using them to add value, improve your data, improve your generation. We should use stewards as the people expertise, improve our data quality, and to actually make data usable in the first place. And we should be embedding ethics at all stages of our research and kind of mindfulness around what we're doing with our data. It's worth collaborating and joining up with communities that can kind of help with this. Obviously, I've mentioned captured ethical data that is best for use in AI systems.
Two fantastic talks there, and I think one of the lessons to bring out, the whole of this is about helping people do a better job and be more productive and more innovative and have more exciting jobs to do it. And so I think there are plenty of warnings in there, but plenty of opportunities. And if we can actually do some of the things that Sammy is suggesting there, we will be able to feed Mike's models with so much better data that people will interact with them and get so many more interesting things. And the UK productivity gap will be closed, and we'll have a future. We have a few minutes left here. If there anybody would like to ask a question, one of the questions that popped up in the chat is bringing common sense. Mike, how do your systems respond to creative requests from people?
Well, we hope we don't get too many crazy requests. I would say a lot of our systems are based in, we've got a lot of mechanistic data, deep process know-how, and that's a bit reassuring to the people in the room around, there's always a human element that we have in the loop at the minute. Right. I will say we are doing some work on a number of facilities. One that we're working on at the minute for a customer in the Middle East, where they want to operate a process plant without any operators, right? Which I've never heard of before, right? So they want to go to almost like a blacked out factory, where the reason for that, by the way, is they've got an exodus of know-how, because most of the operations staff are PhDs. It's polymer plants and the likes, where you've got to have a high degree of knowledge to operate the facility, particularly in grade transitions. You all know that with polymers, I'm sure. It's a tricky subject, and they want to go to drive that consistency and to also drive the quality. They're building a model with ourselves of it's essentially an executable digital twin that run in parallel. But again, it's about having experts, subject matter experts involved, collecting the data, cleansing the data, calibrating the data, So we're not just leaving things to just an AI model to do willy-nilly and end up with hallucinations. There's a lot of guardrails put around these systems to make sure not only we getting good output, but we're asking the right questions. I mean, I always say to people, don't you can judge the person by the answers they give, the knowledge they have, but really the insights are where the questions arise from. So hopefully we don't get too many stupid questions,
Thank you, Mike. I think that's a really good answer to where we are, and I totally agree with you. It's asking the right questions and the good questions. We had some requests that because there was so much in both of your presentations that whether we go to links to the presentations. So we have recorded the sessions. It is the plan to make things available. We will check with both Mike and Sammy that we can make their presentations as available, and so those will be. Now, I know we're getting towards the end of the announced time now, but one of the questions that's popped up is Henrietta is asking about the problem, how if you can't get the people to provide the data in the first place, what do we do? I'm not sure that either of you can produce an answer now, but I think, okay, Mike, please.
So very often, so you might have heard me talk about surrogate models. So we will build a model using classical techniques, and then we will maybe fill in gaps in knowledge using machine learning and the likes, or large language models in that in the AI I mentioned earlier. However, what we will then do, we will train a surrogate on all the permutations. After that model's been calibrated, we will train a surrogate. So you can actually get data where you didn't think you could get data before, and you can get large amounts of data as well, and take you to realms that you may not have even thought of, particularly if you've got that Gen AI model, if you like, the industrial grade AI, has got knowledge from other systems as well. So there's a lot you can do. But again, it's about stewardship and guiding those models in the right way. And that needs subject matter experts. So,
Sammy, you can add something here, please.
So I guess my perspective would be coming at it from, I mean, there's all fantastic ideas. Mine would be coming at it, I guess, again, more from the sort of human element. So why aren't people responding? So is it kind of, you're sending out a survey and they're not replying? Are you going and talking to them directly? Are there ways to get these people in the room together? Are there other easy win mechanisms you could get feedback from them, for example? So, if they're not willing to fill out a survey, would they be willing to have a chat with you? Could you do a focus group? Could you do an interview? Could you even do some really initial VVox polling or something, again, that doesn't take any personal data, doesn't require any ethics approval, but that is quite short and in the moment, but people are more likely to respond because you've already got them in the room. So I guess it's thinking about some of those different mechanisms to get people to respond to you and understanding why they aren't. And then thinking about almost if you can get them in the door and show them some of that initial information, or sometimes even say things that are just a bit provocative, because people like to disagree with people. So it's one thing to say, "Oh, give me your opinion," but if you say something that is going to kind of provoke a bit of a reaction, obviously not being offensive, but a bit of maybe a controversial topic, sometimes people are more likely to then come forward and say, "Oh, well, if you have so much to say about this, then I'd love to have an interview with you," or let's have a bigger discussion about this.
Can I add something to
Mike?
this?
Yes, please.
Well, I don't think it's an option anymore for people to be parochial with the data. I don't think that's an option. I think as students or employees or researchers, whatever else there might be, you've got to liberate that data to the bodies that you work with and for. So that's my opinion anyway, because data is so important to how our future work is made competitive and delivers innovation and the likes. Keeping it in those data silos is I think in the industrial space unimaginable. Now, I can tell you now. You mentioned a moment ago, Jeremy, about why if you want to get to that next level of productivity, you absolutely need leaders that drive organizations to liberate that data. And I can tell you, my job is global, so I work right around the world. And, I can say that, in the Far East, Middle East, there's much more tendency to drive that innovation through leadership roles in industrial spaces than I'm going to say in some of the traditional spaces in Europe. Now, whether that's to do with people are concerned about data getting out and the likes, I'm not sure. I don't feel there's the fear that some of those people have there's a lot of guardrails in industry as well around how data is used and preserved and the likes. But the organizations that seem to fare best are the ones, in my experience, where you've got I'm going to say entrepreneurial leadership at the top wanting to drive this next level of innovation. And if you've got those people, they find ways through. There's not enough of it in Europe, in my experience. I'll be very frank. We've got to.
So I think you're absolutely right. I need to draw things to a close here, Mike. And certainly within organization, we must really be prepared to share. I imagine that some of the problems that Henrietta might be having are people sharing data across organizations that are potentially competitive. So what I would just like to finish there, Henrietta, with a note to you that as you're from Nottingham, you probably are actually aware of the network that we ran, the Internet of Food Things, that was run by Simon Pearson, which inherited from a digital program that I run at the IT as a utility. And there, this issue of exchanging information, and you get to the situation where people don't want to move data up and down the supply chain because confidentiality. And the food chain, as soon as there's a disaster, there's a problem. Everybody understands they need to share as quickly as possible to find the cause, because everybody's damaged. But actually, they're in no position to do so because they've not been sharing. So there are some real issues there about how you get people involved and what you're offering back to them and so on. We actually have a particular interest in, I suspect, in some of the things that you're talking about with farms and farming, and are looking at some stuff with a project from Lincoln. So please feel free to contact Sammy and myself particularly about that. And I'm happy to talk to you and your supervisor. But I think it's illustrative of these problems. We all know that we have to find a way of sharing the data. And if that means we have to protect some interest somewhere, somehow, okay, we have to learn how to do that. And there are ways of sharing the knowledge from the data without the data. And all sorts of things can be done. They may not always be ideal, and then maybe we have to do things in a slightly non-ideal way. But I think what you've heard from Mike and Sammy is it is essential we do this, because it opens up so much, and it opens it up in a way that's reliable. If we don't feed that data in, we will just suffer from, well, you could do this, and if it's got the guardrails in, it'll say you could do that, it might work, it might not, it might do this or whatever, and you've got no further. Whereas we can feed the right data in, keep the transparency there, keep the attribution. Importantly, give the attribution to the people who originated that data. Acknowledge their input to the system. We may have to sort out something beyond patents or whatever, so that the community gets back the effort, something for the effort it's put in. But thank you all for listening. Thank you, Mike and Sammy, for giving brilliant talks, keeping on time. We've got some contact details of people, lots of people thanking you. So thank you for listening, and watch out for more coming from us in this line. And please do come to the conference that we'll be having in the beginning of September 26, where you'll learn much more about this. Thank you again, Mike and Sammy.
Thank you. Take care, everyone.
We'll say bye for now.